Yeah, good evening everyone. Good evening. Good evening everyone. Yeah, let's come all the people one time. Let's come all the people. So you find out your doubts. Which question you have doubt, let me know. Test number 28. Test number 28. Which questions you have doubt? Yeah, good evening. Good evening everyone. Good evening everyone. Good evening. Yeah, test number 28. In today's weekly test. Today's weekly test. Right? Which questions you have doubt? Right, let me know the question number so I can explain. Yeah, you will see after, right? Maybe tomorrow test results will be announced, right? It's okay, right? Johan, try to get from your side maximum marks. Try to get from your side maximum marks, right? Get 25, right? 25 questions are there, right? 25 questions are there. Get 25 out of 25. I asked one of the topper. I asked him how many marks you targeted. Means you want to get the first rank. That's fine. Which rank you targeted? I asked him which rank. That person said to me, I didn't targeted the rank, sir. I tried 100 marks out of 100 marks. Sir, I didn't tried for any rank. I didn't tried for any rank, sir. I tried for 100 marks out of 100 marks. Try 100 out of 100. Forget about, right? How many people are below you? How many people are above you? Just you always target how many marks you are getting. How many marks you are getting. Try to get full. Try to get full. Try to get full. Yeah, it is a today's weekly test. We write test number 28. I'll write data structure test. Please let me know which question you have doubt. Those people who are having any doubt, let me know. Let me know. I will explain one by one. Sir, IIT Madras versus IIT Madras AI versus IIT Delhi Machine Intelligence and DS Data Science. Which one should I take in second round? Machine Intelligence and DS. Yeah, I think go for IIT Madras AI. Go for IIT Madras AI. Yeah, good evening, Rupain. Yeah, let me know. Let's go by one question. Let's go by one. If you say some question number, right, I will go for that also, right? So let me explain one by one. Let me explain one by one. Today's class, right? Today's test number 28. I'm starting now. Test number 28. I will explain one by one question, right? If anything is not clear, let me know. Sir, this is not clear, sir. You ask me, I will repeat one more time. So if you see the question number one, the pre-order traversal of a binary search tree, some pre-order is given. Which one of the following is a post-order traversal? You know very well, right? You know very well. Pre-order of BST given. Pre-order of BST given. So if you see the pre-order of BST, so 15 there, 10 there, 12 there, 11 there, 20 there, 18 there, 16 there, 19 there. That is the pre-order. So if you see the in order, you know ascending order, right? In order, if you see 10 there, 11 there, 12 there, I think 15 there, 16 there. Next one is I think 18 there, 19 there, 20 there. So I think above if you see 3 plus 2, 8 people. So here also 8 people. Yeah. So by mentioning the BST, they are given the in order. In order of a BST is a sorted order. Everyone know. So you can easily find out. So who will be the root? 15, 15 is the root. What is the 15 left subtree? This one. 15 right subtree? This one. Now do the recursion again. So what is the meaning? What is the meaning? See this one. In the in order, if you see left people 3, right people 4, that means next 3 people are left people, next 4 people are right people. So in the left people, again take this free order, take this in order. Do the same story. 10 is the next root. If 10 is the next root, 10 left is no one, 10 right is this. So 11, 12. Right? So I think left no one, right is 2. Left no one, right is 2. So these 2 people are right. Right? If you see the next one, next root, I think 12 is the next root. So left is 11. So like that you can easily find out. So if you go further, can you see the right side? Right side next root is 20. So 20 left is I think all 3 people, right no one. So 16, 18, 19. Now out of these 3 people, right, 18 is the next root. So 18 left is 16, 18 right is 19. So 18 is here, 19 is here. Right, 18, next root is I think 18. So left is going to be 16, sorry for this. Left is going to be 16. Right is going to be 19. Yeah, this is the one. So let's go to the post order. First 11, next to 12, first 11, next to 12, next to 10. Right, afterwards if you see 16, afterwards 19, afterwards 18, afterwards 20, afterwards 15. So B is the answer. Is it okay? B is the answer. Is it okay? Question number 1, B is the answer. Someone is saying question number 4. I will explain. Question number 1, B is the answer. This one we are already covered in the class. This problem we are already covered in the class. This one we are already covered in the class. Question number one, just I think the major key point is this one only, BST. The major key point is this only, BST. Pre-order is given. So to construct the tree, actually 2 people required. Pre-given, in order required. How to get in order? Because of this in order came. Using these 2 things, draw the tree. So I think B is the answer, everyone know. Right, let's go to question number 2. Right, I think it is a linked list question. What is the worst case time complexity of inserting n elements into an empty linked list, one after another, if the linked list needs to be maintained in sorted order after every insertion? Already linked list contain n people, they are already sorted. After every insertion, right, you have to make sure. See this one. What is the worst case time complexity of inserting n elements into an empty linked list, one after another, if the list needs to be maintained? I think everyone know. So initially empty, you will insert 1 person, right? It became 1 node. Right, afterwards you will insert one more node. But after every insertion you have to verify, is it sorted or not? If not sorted, you have to sort. So what I want to say is, let us assume that 10 there, 15 there. See this one, 10 there, 15 there, 20 is there. It is a linked list already there. 10, 15, 20. One more element, 25 is coming. You have to ask every person. Worst case, you have to go extreme corner, 25. If you want to insert one more person, you have to ask every person. Suppose he is 18. So 18 will comes to here. So you have to insert like this. So every time you have to take care about sorting. Every time you have to take care about the correct place you have to insert. Every insertion will take order of n time. Like that, n times you are doing. So I think n square. Every insertion is n time. Because if you cannot insert wherever you want. You have to insert in the sorted order. Some people are asking, sir, suppose assume that now element 5 will come. Where I will add? Element 5 is coming, insert in the starting only. So best case for every insertion is 1. Worst case, every insertion is n. You have to go to last place. Suppose I want to insert element 23. So I will ask him 23 more than this. 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 I will ask him 25 less than this. So here. So 23 will be here like this. The advantage with the linked list is wherever you want, you can insert. Just changing links only. The drawback with the linked list is finding correct place will take more time. Finding correct place will take more time. After going to correct place, linking will take only constant. After going to correct place, linking will take only constant time. After going to correct place, linking will take constant time. So every element to go to correct place, right? Worst case n, maybe extreme rightmost place. Because of he's asking worst case, I have to think about worst case. Extreme right you go. Go extreme right, every time n, every time n, every time n, the worst case n square, right? Answer is option C. So question number 2, answer is C. Any debate on question number 2? If anyone having any doubt on question number 2, please let me know. Question number 2, if anyone having any debate, sir, can you help me with this sequence comparison? Fn is equal to 3n square root of n, gn is equal to, so you can, Abhiraz, you can send in our group. You can post in our group. So I can, right, if I keep on try something here, my problems will be gone. So the purpose of today's class is I want to explain all my 25 questions. Whichever happened in today's test, all 25 questions I want to discuss, right? That is the reason I came here. So you can post in our group, right? Definitely, right? I will look into it. Yeah, so this is the problem. What is the worst case time complexity of inserting n square element into an AVL tree with n square initially? So see the beauty. AVL tree already contain n square people. AVL tree already contain n square people. You want to insert one more n square people. AVL tree already contain n square people. You want to insert one more n square people. So you know very well, one insertion will take, if n elements are there, one insertion will take log n. If n square elements are there, one insertion will take log n square. One insertion is log n square, like that n square time, n square into log n square. This can be written as n square into 2 log n. This can be written as 2n square log n. 2 is a constant. It will goes to theta of n square log n. Answer for this problem is theta of n square log n. In the AVL tree, one insertion will take log n. Right? In the AVL tree, one insertion will take log n if n elements are there. Log n square if n square elements are there. One insertion log n square, two insertions 2 log n square, n square insertions n square log n square. N square log n square. So answer is going to be n square log n. If anyone done small mistake also, see, it is not final exam. It is not final exam. If anything wrong, rectify. Right? We are conducting tests. We are conducting tests not to criticize you. We are conducting tests not to decrease you. For every test, if you are decreasing, then why are you writing test? Every test, right? Some marks, right? Less marks came. Every test you are getting less marks. You are decreasing yourself. Then why are you writing test? Then why are you studying entire year? Everything, whatever you write, the test name itself saying it is a test. It is the test. Test means, right? Oh, some difficulty there. So you identify your mistakes, rectify. Don't repeat in the next test. Don't use a test for demotivating you. Don't use a test for decreasing you. Don't use the test for misusing. Test purpose is improving you. Test to test improve. Test to test improve. You got negative marking. It's okay. You got negative marking. It's okay. See this one. Test is happened morning 8 a.m. Test is happened morning 8 a.m. Right now, explanation is going on. Almost like 8 p.m. Test is happened morning 8 a.m. Explanation is going on 8 p.m. In between, you could have rectified. In between you could have verified. In between you could have verified. Right? So I given answers also. Please discuss yourself. Please discuss yourself. Anyone done wrong? After test over, I given the key also. Please, right? Please match. If something is wrong, go to the notes, revise. Go to the notes, revise. Nothing will happen in single day. After last exam is over, don't cry. After last exam is over, don't cry. I got this, Reddy sir, what I will do? Right? I got very less marks, sir, Reddy sir, what I will do? No one will help you, yaar. After exam is over, everyone will ask, what is your rank? Exam is over, everyone will ask you, what is your rank? Because after exam is over, people have want results. Right? Now, whenever weekly tests are going on, please improve, yaar. This is the time to improve. After final exam is over, whether I will give key or not doesn't matter. After final exam is over, whether I will explain or not doesn't matter. These things matter. These things matter. Do your level best now. Don't ask me after exam is over. After exam is over, I don't help you at all. This is the time for improvement. It is there in your hand. Please improve. So the answer of this one is n square log n. N square log n. I think Johan is saying that number of comparisons are 1 plus 2 plus 3 plus and so on, of course, which is nothing but n square. Right? After exam is over, don't cry. Because actual work is going on now. If you do nice work now, nice rank will come. Suddenly, nothing will happen. So can you come to problem number 4? Problem number 4, it is related to arrays. Problem number 4, it is related to arrays. Can you see this problem? A program P reads 500 integers in the range 0 to 100, representing the scores of 500 students. There are 500 integers in the range from 0 to 100, representing the scores of 500 students. It then prints the frequency of each score above 50. What would be the best way to P to store the frequencies? It is something like this. Listen, it is something like this one. There are 500 students. I conducted the exam. See this one. See this problem. There are 500 students. I conducted the exam. Exam is over. Everyone got the marks from 0 to 100. 500 students, I conducted the exam. Everyone got the marks from 0 to 100 some number. Right? 0 to 100 some number. See this one? In the range representing the scores of 500 students. Okay, exam is over. Exam is over. 500 people are written the exam. Student number 1, he got 75 marks. Student number 2, he got 55 marks. Student number 3, he got maybe 7 marks. Student number 4, he got maybe 0. Student number 5, maybe he got 60. Student number 6, maybe he got 55. Something like that. 500 people are there. Now see your goal. It then prints the frequency of each score above 50. What would be the best way for P to store the frequencies? See this one. You have to store only frequencies. And he's saying that it then prints the frequency of each score above 50. So what finally it should do is, this is the input. Everyone listen, this is the input. Now it has to print in such a way that, right, it then prints the frequency of each score above 50. Above 50. What is the meaning? 51, how many students got? 51, 3 people got. 52 marks, 7 people got. 53 marks, 10 people got. 54 marks, right? I think 18 people got. 55 marks, I think 0 people got. 56 marks, right? I think 9 people got. 57 marks, right? And so on, until 100. And one more thing is, what would be the best way for P to store frequencies? I think you have to store only this. I think in the array first place store 51. In the array second place store 52. In the array third place store 53, and so on. I think an array of 50 numbers are more than enough. An array of 50 numbers are more than enough. An array of 50 numbers are more than enough. Listen, see this one. What would be the best way for P to store frequencies? And important thing, remember, it then prints the frequency of each score above 50. We want that only. It then prints the frequency of each score above 50. What would be the best way for P to store frequencies? Yeah, minimum 50. It then print the frequency of each score above 50. What would be the best way for P to store the frequencies? Even though if you store 1 to 100, what is the use? Because he is using only above 50 only. He is using only above 50 only. Please let me know. It then print the frequency of each score above 50. What would be the best way for P to store the frequencies? 51 how many? 52 how many? 53 how many? According to requirement, to store the frequencies, how much space required? So in the first index store 51 how many? Second index store 52 how many? Third index store 53 how many? And so on. 50 index store, 50 index store, 50 index store. Last index, right? 50 index store, 50 index store, 100 how many? 50 index store, 100 how many? Right, like this. Yeah, that's what I'm saying. See, what is the requirement? See, it then prints the frequency of each score above 50. Frequency means 51 how many people got, 52 how many people got, 53 how many people got, something like that. Fine, can we move to next problem? Yeah, then it could have been option B. Row pine, then it could have been option B. He is given the target also. It then prints the frequency of each score above 50. So according to problem, we have to follow, right? Fine. Can we go, Johan? Can we go to next problem? Can we go to next problem? So my request to everyone, please write every week test. Please write every week test. Please write every week test. Rectify what mistakes are going on. See, if you don't write test, whatever subjects you completed, you are gone. See, someone is completed, I'll go. Someone is completed, I'll go. Right? I'll go. Whenever I'll test is there, weekend test, please write it. Whenever I'll weekend test is there, please write it. So you completed TOC. Whenever TOC test is there, weekend test, please write it. See, 28 tests are happened. 28 tests are happened. Whichever subject you completed, please complete that weekend test. You completed, I'll go. You completed, I'll go. Every week, one I'll go test you write. You completed TOC. Every week, one TOC, right? One TOC test you complete. Please do like that. Please do like that. Approximately 60 weekend test will be there. So classes followed by 60 weekend test you do. Right? Most probably you are perfect. Lastly, write one test series. It is more than enough. Lastly, write one test series. It is more than enough. Yeah, sir, please listen my doubt. What is your doubt? It is not required, right? See the problem. It then prints the frequency of each score above 50. What you want to store? No use, na? If you want, you can store, but see the question. It then print the frequency of each score above 50. Okay, you store. What is the use? Yeah, you could have given the problem little more clearly, little more clarity could have mentioned. But anyhow, by seeing that, see, otherwise, what is the use of this line? Otherwise, what is the use of this line? Otherwise, what is the use of this line? It will print the frequency of each score above 50. What is the use of that line? If that line is not there, answer could have been option B. If that line is not there, answer could have been option B. Yeah, don't waste time on easy question, right? Perfect, perfect, perfect. Now see the question number 5. Question number 5, see this one. Question number 5, if you observe, see this one. Question number 5, if you observe, see everyone. Question number 5, if you observe, C value 100. C value 100. Now see what is going. For every combination of ij, is doing one thing. Let us assume that I value 2, j value 5. I value 2, j value 5. Let us assume, it is a 2D array. It is a 2D array. It is a 2D array. Let us assume that it is the second row, it is the fifth column. Second row, fifth column, it is a 2, 5. 2, 5, 2, 5, assume that 70 there. Second row, fifth column, 70 there. Okay, let us assume. Now, if you see, right, what exactly is doing? Second row, fifth column, and one more thing, fifth row, second column. Fifth row and second column. It is, let us assume that it is a 90. So 2, 5, reverse if you see 5, 2. Reverse if you see 5, 2. Now see, if at all these, whenever this program is going on, listen, whenever this program is going on, he will take aij, I think, let us assume that it is a 2, it is a 5, a25, which is 70. 70 plus 100 is going to be 170. 170 will store in the temp. Next one, right? So temp is 170. J value is 5, I value 2, A52, which is 90. 90 will store in 25. So 70 place, right? 70 place replaced by 90. 70 place replaced by 90. Right? Next one. Temp minus C. Temp is contain 170. Minus C means 100, which will goes to 70. 70 will goes to A52. A52. So that means 90 place 70 will go. Simply swapping. Remember, I value 5, j value, see, I value 2, j value 5. Whenever I value 2, j value 5, they are swapping. Whenever I value 2, j value 5 means 2, 5. 2, 5 time is swapping 90 here, 70 here. Whenever ulta happened, after some time, this for loop will go, I value 2, j value 5 becomes some point of time, I value 5, j value 2. That time, same thing will be reverse happen. So it will goes to 90, it will goes to 70. What I mean to say, 2 times you are swapping. 2 times you are swapping. I value 2, j value 5, right? You are swapping, right? You are swapping 70, 90. It will goes to 90, it will goes to 70. Whenever this loop is going on, some point of time, it will become 5, it will becomes 2. Then again you will swap this one, 70 here, 90 here. 2 times you are swapping. I think answer is going to be, right? So the matrix A itself, if you do one time swapping, I could have said something, right? The matrix A itself. Fine. Same thing you are doing 2 times. If you do one time, okay. One time swapping, okay. You are doing 2 times swapping. So answer is, I think, for this problem, right? For these 2 times you are swapping. Question number 5. Answer is going to be A. Everyone fine. Go to the question number 6. So in the C programming language, at most one activation record exists between the current activations. Let us assume that. So this is the program. Listen, Let us assume that one program is going on. See this one program. Main calling A calling B calling C calling D. Whenever main called, main will push. Afterwards, A call, A will push. Afterwards, B call, B will push. Afterwards, C call, C will push. Remember, the number of people who will push inside stack, it is completely based on how many people you are calling. Yeah, maybe. Yeah, learn. Shakir, from your mistake, please learn. Right? So you see this one. I know that it will happen. See, whenever I am making test, see this one. Test is 8 o'clock. I woke up around maybe 4:30, something like this. I woke up at 4:30. I verified one by one. I think maybe students will think like this. Oh, swapping. They may think that transpose. Let's do 2 times swapping. Yeah, someone is saying that, someone is asking me, what is the activation record? See this one. I think main is called means main information will push, right? Main activation record contain main local variables, some stuff related to main. Whenever main called, main information will push. Whenever A called, A information will push. A function information is nothing but right? I think A details. I think A is having internally some local variables. All the stuff related to A will be there. So anyhow, Johan, you will get this one in the compiler. In the compiler, there is a activation record story. There we will discuss. Remember, main is pushed means main activation record will push. Main will push means main activation record will push. That means main information will push. That means main local variable. Some more stuff. There are so many things are there. So in the compiler activation record, it will come. Is it okay? Compiler activation record, it will go. In the compiler one chapter, runtime environment. There we will discuss more details. Remember everyone. In the stack, how many people are pushed? In the stack, how many people are pushed? It is completely based on how many functions you are calling. If I call 5 people, 5 activation record will push. If I call 10 people, 10 activation record will push. Every function call is a one push operation, right? Instead of saying, right, M function is pushed, say M activation record is pushed. Instead of saying M is pushed, M activation record is pushed. It means M information is pushed. There is a one list is there. Activation record contain approximately 7 fields are there. I want to list out all, but anyhow, in the compiler you will see that. In the compiler you see that. Number of call is equal to, right? Every call is a one push operation. Suppose function is over pop operation. Function call push operation, function over pop operation. Right? Fine. In the C programming language, at most one activation. How can you say this? How many people are called? Those many. How can I say that? At most one activation record. It is completely based on how many you are calling. If you call 25 people, 25 functions are pushed. 25 activation records are pushed. He is saying at most one. So wrong. Option B is saying that the number of activation record between the current activation record and the activation record for the main depends on the actual function calling sequence, of course. The visibility of a global variable depends on the actual function calling sequence. The visibility of a global variable depends on the actual function calling sequence. Global variable visibility, it is not depending upon the function call. Any function can see it. And one more beautiful thing, listen, one more beautiful thing, whenever recursion is going on, let us assume that recursion going on. A function calling itself is recursion. Let us assume a function call itself 25 times. A function called itself 25 times. That means A pushed 25 times. A pushed 25 times. Remember, A is called itself 25 times. A pushed 25 times. All pushed in the same stack. But he's saying recursion required the activation record for the recursive function to be saved on a different stack before recursive function can be called. So no, all the, listen, A called itself 25 times. All 25 will push in the same stack, not in the different stack. Different stack means there is no meaning. Different stack means there is no meaning. Right. So question number, I think, yeah. Question number 6, answer is B. Can you go to question number, right? Question number 7. Question number 7. Suppose each set is represented as a linked list with elements in arbitrary order. Which one of the following union intersection membership cardinality will be slowest one? Remember everyone. Membership means in the given linked list, my element X exists or not, one scan required. Membership will take n time, worst case. Cardinality means in the linked list how many elements are there? In the linked list how many elements are there? In the linked list how many elements are there? That is called cardinality. I think one time I have to count this also n. This also n. Membership n, cardinality also n. Now see this one. Union and intersection. Remember everyone. It is the linked list. Careful. It is also linked list. Everyone observe. It is the linked list L1. It is the linked list L2. Two linked lists are there. Linked list L1, linked list L2. Two linked lists are there. You want to do intersection. So what you do is first linked list sort n log n. Second linked list also sort n log n. After sorting both, do merge algorithm. Do merge algorithm for union also, for intersection also. Do merge algorithm. We are already covered in the classroom. Whenever merge sort is going on, we are already covered it. Whenever merge sort is going on, we are already covered this problem. Two linked lists are there, you want to do intersection. Both the linked list, do sorting first. Then apply merge algorithm for union also, intersection also. So merge algorithm will take one more n time. If at all n people here, merge algorithm will take 2n, which is nothing but n time. So final answer is sorting will take n log n, merging will take n time, overall is n log n. So remember union and intersection both will take n log n time. So final conclusion, union will take n log n, intersection will take n log n, membership will take n time, cardinality will take n time. Is asking which one of the following operation, slowest one. Slowest means taking more time. More time is union intersection. Answer is D. Membership means in the linked list X is exist or not. That is called membership. You have to do one scan. Right? In the linked list, how many elements are there? You have to count once. One scan, which will take n time. Right? And one more. Two linked list if you want to do intersection. First to sort both of them, sorting will take n log n. Right? Afterwards, do merge algorithm, which will take n time, 2n log n. Right? If you take both the sorting, 2n log n. Right? And merge algorithm, so 2n, which is nothing but n log n. So approximately I written. Answer is n log n. So slowest operation means taking more time. Right? I think union intersection will take the more time. Question number 7, answer is D. Go to the question number 8. Consider a single linked list. I think something is given where F is a pointer to the first element and L is so it is a linked list. F is a pointer to the first one, L is a link, right? L is a pointer to the last one. But remember everyone, in your group also I seen, see this one, single linked list. Yeah, someone is saying that, but they didn't say after union, element should be sorted. So why are you doing sorting and union? Yeah, so please let me know less than n log n possible. Johan, please let me know if less than n log n possible. That is a nice question. I am very happy for your question. Is there any way less than n log n? So one more thing, Johan, so try to understand, Johan. First linked list contain 1, 2, 3, 4. Second linked list contain 1, 2, 3. If you do union, blind union, if anyone do blind union, see this one, 1, 2, 3, 4, 1, 2, 3, you will get. It is a blind union. If you do meaningful union, 1, 2, 3, 4, union 1, 2, 3, answer is 1, 2, 3, 4. Means repetition is not allowed. If repetition is not allowed, you have to check is it exist or not. The best idea is sort them, right? Unnecessary people you can delete. If you do blind one union, right, Johan, if you do blind, it will look like this. Blind union you done, it will look like this. Repetition is coming. 1, 2, 3, 4, 1, 2, 3. If you do blind union, 1, 2, 3, 4, 1, 2, 3. But the actual answer, 1, 2, 3, 4 only. It is the actual answer. If you do blindly, answer coming like this, which is wrong. To get this one, the solution is sort this one. Just to do merge algorithm. Merge algorithm will take the remaining part. It is there already. So the best idea is, Johan, best idea. In the merge sort, right, last portion, right, this problem is covered. In the merge sort, last portion, this problem is covered. Please take care. Yeah, come to the question number 8. Question number 8, starting of the linked list is F, ending of the linked list is L, right? Single linked list. He mentioned single linked list. Please be careful. Single linked list mentioned. Remember, next one. Now he is asking which one of the following operations is one. For which one of the following operation, the corresponding time depends on the length of the list. Add an element after the last, right, element, after last element because of one pointer there. You can easily do this linking. So I think you no need to go from starting to ending. So depends on the length of the list. It is not depending. Delete the last element. I think everyone know. If you want to delete last one, if you delete the last person, before is the end of the linked list. If you delete the last one, before is the end, means you have to make it as null, but you cannot come back. So you have to go from here, which will take n time. Add an element before the first element. I think it will take constant time. Interchange the first two people. It will take constant time. This will take constant time. This will take constant time. This will take n time. This will take constant time. So B is the answer for this. Yeah, fine. Perfect. Can you go to the next one? Right. So linked list. Right. So it is also linked list question. So double linked list. Remember, it is a very interesting question. Question number 9 is the very interesting. See, double linked list contain the greatest advantage of the double linked list is double linked list contain 2 pointers. Double linked list contain left pointer, double linked list contain right pointer. The advantage if you have 2 pointers is because of some reason you lost one pointer. With the help of another pointer you can get it. Let us assume that, right, this is P, this is Q. See this one, P next is equal to Q, Q next is P. Everyone know, because of some reason, if you lost this link, right, using Q next, right, Q previous is equal to P, right, then you can write P next is equal to Q. You can write, means because of some reason if the first link is broken, with the help of second link, you can get it back. The greatest advantage of the double linked list is recovering a pointer which you lost. If you lost one pointer, with the help of another pointer you can get it back. Fine. The greatest advantage of the double linked list, because of 2 links are there. If you lost one link, with the help of another link you can recover it. It is something like having 2 keys. One key you lost, with the help of another key you can recover it. Right? You have 2 keys, one key you lost, with the help of another key you can recover it. Fine. And one more thing I want to say to you, those people who are watching, if you are serious about GATE exam, if you are serious about GATE 2025, if you are serious about GATE 2025, right? So I think, right, if you are serious, you can join, right? If you are not joined anyway, you can join happily EPT. You can join happily EPT, right? We are going to help you. And 25% offer also going on. 25% offer also going on. Today it will be over. You can utilize it. If you are serious about GATE 2025, right? If you want to join UPT, you can join today. 25% offer is going on, right? We are going to guide you. Definitely it is going to be useful thing to you. Let's come to the next problem. Question number 10. Which of the following is true? Which of the following is true? It is something like AVL tree. Everyone know AVL tree searching becomes a login, deletion also login, insertion also login, everyone know, right? So he's saying the cost of searching an element in the AVL tree, theta of login, but that of binary search tree is order of n. Yeah, AVL tree, every case, AVL tree, every case is theta means all cases, almost like all cases, right? AVL tree, all cases almost like, right, login. But in the case of the binary search tree, right, binary search tree, right, almost like upper bound is n, right? In the case of the BST, upper bound n. In the case of AVL, every case is almost like login. So this is true. But listen everyone, if I say, everyone listen, if I say binary search tree time complexity, theta of n is wrong. Now I will give the answer. I will give the reason for this. Sir, binary search tree, if I give theta, it is wrong. Why? Let's see this one. When you say binary search tree, listen, when you say binary search tree, best case is 1. When you say binary search tree, best case is 1. Worst case is n. Average is log n. When you say binary search tree, best case 1, worst case n, average case log n. Now can you help me now? These three people, big O of n will work or not? Of course, right? So left side 1 is there, n is there, log n is there. Is equal to big O of n. Everyone happy. He is saying I am okay. He is saying I am okay. He is saying okay. If I write theta, theta means both the side equal. If I write theta of n, see the problem. Theta means both are equal. Are they equal? No. He will say no. Are they equal? Yes. Are they equal? No. So remember, if all will agree, then only you can keep. So if it is the theta, you don't agree. E also don't agree. If it is the n, everyone agree. Now come to the AVL tree. Listen, come to the AVL tree. Best case also log n, worst case also log n, average case also log n. All three people agree with this. All three people agree with this. All three people will agree with this. Right? So please be careful. Left side people, right side people, if all agree, that is right. So left side people, three people are agree with the right side person. So AVL tree perfect. But in the binary search tree, if I keep the theta, if I keep in the binary search tree theta, if I keep theta, this person saying I don't agree. This person saying I don't agree. So big O is correct. If they write theta, it is wrong. Please careful. So overall option A is right. Let's go to option B. Listen, let's go to option B. AVL tree means AVL tree searching will take every case log n. Log n is theta of log n, of course. But that of complete binary tree, see, complete binary tree means no gap. It is not for searching purpose. He is saying n log n, so no relation. The cost of searching binary search tree, right, big O of log n, no, because if some people are asking, sir, why it is right, wrong, sir? See this one is there, log n is there, n there. How can I say n is big O of log n? He is okay, but he is not okay. He is not okay, so it's wrong. The cost of searching an AVL tree is theta of n log n, wrong. Answer is A. Answer is A. Please be careful. Nothing there. Please study big O omega theta properly. When you say theta, left side person equal to right side person. But when you say big O, comparing left one, right one is bigger. When you say omega, comparing left one, left one bigger, nothing there. So just checking some basics. Whenever symbols will come, don't bother, right? Please think properly. Please think properly. I hope you got it. I hope you got it. I hope you got this. Someone is saying, what about predecessor? Yeah, Rupain, you are saying something. Please let me know. Rupain, you are saying something. Please let me know. Yeah, so 9, question number 9. Someone is saying question number 9. Is it question number 9? Yeah. Question number 9, what is saying? What about predecessor? Access an item, so recovering a lost pointer, copying a list, merging two lists. What is the meaning of predecessor? Yeah. So, right, sometimes, right, Johan, sometimes it will create trouble. With the, even you didn't verify it, still it may work out. Sometimes it may work out. Yeah, let's see. A double linked list facilitates the determination of the predecessor of a given item. Means normally single linked list, next one, right? Normally single linked list, next one, right? In the double linked list, predecessor means previous one also. Am I right? A double linked list facilitates the determination of the predecessor of a given item. In the single linked list, as compared to single linked list and double linked list, single one will give next only, but this one will give previous also. Which of the following, right, operations utilizes this property of a double linked list to its greatest advantage? Right? Fine. Nice question. So can you come here now? So be careful with the operations. If anyone is not getting, listen. If you want to use, careful everyone. If you want to use big O or you want to use omega, you want to use theta, left people, right people. See this one. Both should agree. Listen, everyone should agree. You want to use big O, left big O of right. Left big O of right. Remember, all left people should agree. If you want to use big O, all left people should agree. If you want to use omega, all left people should agree. If you want to use theta, all left people should agree. Please check how many left. See, AVL tree. See this one. Searching an element in AVL tree. These are the left people. This is the right person. Can I use theta or not? Check. Right? When, if you want to use big O or omega or theta, right, all left people should agree. Searching an element in AVL tree. 3 people are there left side. 1 person there right side. Is everyone agree? Yes. Now if you go to the option A, second part, but BST, see, searching an element in the BST, best one, worst n, average log n. Right? Left is 3 people, right is right n. I want to use big O. Is all are accepting? Yes, all accepting. Because the big O is accepting, all accepting. If it is theta, some people don't accept. Because of that reason, it is right. So remember, if you want to use big O, all left people should agree. Omega, all left people should agree. Some people agree, some people not agree, you cannot take. Adib Chowdhury, big fan. Please take my name. Thank you. Thank you so much. Thank you, Adib. Thank you. Yeah, I took. Thank you, Adib. Yeah, so Adib is one of my student, right? Adib, thank you so much. Right? Nice to see you after a long time. Right? It was nice to see you after a long time. Thank you so much. So yeah, can we move to next problem? Right, 10 problems are done. Let's go to 11th problem. Let P be a linked list. See this one. I think here some problems are there. Everyone listen. Here there is some small twist there. People are misusing this. People are misusing People are misusing the question number 11. Can you see this one? There is a single linked list. P is a single linked list. Can you see this? This one people are misusing. Can you see this one? It is P. Let P be a single linked list and Q be the pointer to an intermediate node X. Maybe it is a Q. So let me write the data. A, B, C, D, E, F. A, B, C, D, E, F. Okay, fine. That's okay. What is the worst case time? Worst case complexity of the best known algorithm to delete the node X from the list? You want to delete this person. Q be the pointer to an intermediate node X in the list. So you want to delete this person. What is the worst case time? Remember everyone. So pointer Q given. But if you want to delete this one, previous one you have to change like this. Previous link you have to change. Because of single linked list, you cannot go back. Because of single linked list, you cannot go back. So you have to come like this. You have to come with friend from this. Worst case, this person can be close to last node. Worst case, this person can be close to last node. Worst case is order of n. But some people are suggesting me, sir, you cannot go back. Some people are suggesting me, you cannot go back. So that is the reason what they are doing is, you want to delete this D. Listen, you want to delete this C. Some people are doing like this one. You want to delete this C, you cannot go back. You have to change actually going back and you have to change like this. But some people are saying that, sir, what I will do is, I cannot go back, but I can go forward. So this D replaced by E. This D replaced by E. This one I will delete, sir. This one I will delete. Right? This one I will delete. Some people will say that. That's what I'm saying. Some people, right? I'm repeating once again. Some people are saying that, sir, you cannot go backward, but you can go forward. Nah. So forward data copy here, and you delete this person. Remember, it is something like this. Everyone observe. It is something like this. I want to kill someone who is having, right? I shown like this. See this one. I shown in the crowd like this one. Right? I said to one of the professional killer, you have to kill in that crowd. There is a one red color shirt is there. In the crowd, there is a one red color shirt. That person you have to kill. I said to professional killer. If he is a correct person, he will kill that red color shirt only. If at all is a correct person, he will kill that red color shirt person only. But what he done is, he killed someone to that person, he kept a red color shirt. I asked you, kill in that crowd who is having the red color shirt. There is one person who is having the red color shirt. Instead of you are killing him, you killed someone else. You kept the red color shirt to him. Are you getting what he is saying? Right? Let Q be the pointer to an intermediate node X in the list. What is the worst case time complexity of the best known algorithm to delete the node X from the list? So you have to delete this. You cannot delete someone. You cannot change the shirt. Are you getting? This trick may be, everyone listen, this trick may be useful. Right? In the interview. If at all this question is given, listen, if at all this question is asked in the interview, if at all this question asked in the computer science interview, technical interview, they asked you, you say like this. See everyone, you say like this. In the interview, they asked you this question. You just say like this. Delete a node pointed by Q. Just you have to explain properly. Delete a node pointed by Q. Right? Now say, sir, if I want to delete this, let me use the another color also. Sir, if I want to delete this one, everyone listen, if I want to delete this one, so, right, I have to go to previous. I have to inform to previous one. Your next is not D, your next is E. I have to inform to the previous one. But it is a single linked list. I cannot go back. So I will come from starting with my friend. I will be at here. My friend is here. I will complete the formalities. So to come from starting, it will take order of n time. Worst case n. When you say like this, listen. When you say like this one, worst case n and everything, he will be very happy, but he will say one more line also. He will say, better than this possible. He will say, whatever you said is true, but better than this possible. Oh, array man, you want that, right? You want that worst one, killing someone, right? Wearing the red color shirt to him, right? Oh, you want like this. Now say to him, yeah, maybe you are expecting like this, sir, right? Maybe you are expecting like this. I cannot, right? If I want to delete this one, I cannot go back. So I have to come starting and all. I done like this. But you may be thinking like this one. I will go forward because of I can move forward direction. So I can go to the next one. So next person data copy here. Then delete the next person. Then delete the next person. Right? If I do like this, it is coming as output like you. But the thing is, I am not deleted pointed by Q. I deleted something else. It may be looking like this, but actual deletion is not this. See, best known algorithm. Not, right? He is asking best known algorithm, not cheating algorithm. Not faltu algorithm. Not cheating algorithm, not faltu algorithm, not buffoon algorithm. Not buffoon algorithm. Are you getting? It is a cheating on this. I asked you delete Q. How can you delete Q next? How can you say that you deleted Q? How order n came? Go X, right? That element may be their extreme right. He is asking, see this one. Worst case. That element, which element you want to delete? That may be extreme right. You have to go from starting to there. You have to go from starting to that element. Suppose you want to here X is there. You come to here, your friend will be before. From starting onwards, you will come to here, your friend will be before, because you want friend before. See, you have Q, but you don't have friend. The problem here is you don't have friend. Array man, get Q. Then what you understand the problem here? If you want to delete Q, pointer given. But deleting Q means you have to change the previous person. It is a single linked list. You cannot go to previous. So you have to come from starting to before Q. That is the debate here. So interview person is expecting like that. See, all interview people are like this only. They don't know actual concept also. Just they are saying, see, one question, one answer. They will ask their colleagues, I am going to the computer science technical interview. Can you give few questions to me? Right? I am going to the computer science technical interview. Can you give few questions to me? Right? He will say one more thing also. Some tricky questions required. Sir, but deleting a node doesn't mean changing the value. You have to delete Q, na? What is the series one? Let Q be the pointer to an intermediate node X in the list. What is the worst case time complexity of the best known algorithm to delete the node X from the list? You have to delete Q. They didn't ask you change the data, change the previous, right, next data to your data and delete someone else. He didn't say to you. See, he said very clearly, best known algorithm. He knows very well you will do some faltu algorithms. See, how can you change it? If I ask you delete a node pointed by Q, if I ask you delete a node pointed by Q, please delete it. How can you copy the next one? How can you delete like this? It may be worked out in the interviews. Please take care. Fine. Can we go next? I asked you delete a node pointed by, right? Delete a node pointed by Q which contain data X. You cannot copy that. That is a little bit convincing. So in the interview you can say. So that is also one of the possibility. It's almost like manipulating. You only say, I asked you kill that person who having a red color shirt. How can you kill someone? How can you give the red color dress to him? Time complexity means all. When you say worst case means worst case only. Time complexity means all you have to calculate. Worst case means worst case. Fine. Can we move further? Can we move further? Can we move further? Are Johan, can we move further? Delete a node pointed by Q. Simply delete Q. Simply delete Q. Delete a node pointed by Q. Simply delete Q. Don't do manipulation. They are also correct, maybe interview point of view. They also correct, maybe interview point of view. If interview person say, I didn't convince you. Whatever you said, I didn't convince you. Oh, you may be expecting this. So you say that also. I cannot go back, but you are expecting some better answer. So even though it is wrong, I can do like this. Even though it looks like wrong, I can do this. Go forward, because you can go forward. Next node data, copy in the current data. Next node delete. But interesting thing is, I am not deleted Q. I deleted Q next. It may be look like similar. It may be look like similar because you said to me, delete the Q. But I deleted Q next. But finally it look like similar. That is the reason maybe you are thinking it is correct. Right? But I am not deleted Q. I deleted Q next. Someone saying best case one. What is best case, right? See, best algorithm. Oh, you are saying best case. Maybe starting node. Fine. Rupine, maybe starting node. Best case one. Maybe best case one, right? Starting node, right? Go to the next one. Question number 11 over. Go to the question number 12. Question number 12. The concatenation of two lists to be performed order of one time. Which one of the following, right, implements? Remember everyone. Very interesting. See this one, very interesting. It is a circular double linked list. See this one. It is a circular double linked list 1. It is a circular double linked list 2. Careful. It is a circular double linked list 1. It is a circular double linked list 2. You want to concatenate both. Listen. You want to concatenate both in order of one time. So what is the answer? When you say circular, listen, when you say circular, you can go directly here. Link it. You can go directly here. First to last, you can go happily directly. Double linked list, I cannot go first to last. So if you want to link both of them, you have to go to first to last. Because of circular double linked list possible. Right? I think first to last possible directly. First to last possible. Some small adjustment. Remember, circular double linked list. In the double linked list, I cannot go first to last. Concatenation means this area should be changed. Concatenation means this area should be changed. So you have to go to starting to here. Right? Most of the, right, Johan, most probably interview people are like this only, right? They want some fancy answers. You say first of all practical things. Don't fight with them. Johan, don't fight with the interview people because they don't select you finally. Don't say you are wrong also. Don't say interview person you are wrong also. Don't criticize. because they, so even though you are so good, finally he is the person who will select you. So say first of all whatever you are thinking. If you say I want better than this, maybe you have to think, oh, you maybe want like this. Yeah, you can say, sir, I cannot go backward, but I can go forward. I think I will replace the next data here. Next data I will delete. Right? So this is also looks like a correct answer. But the interesting thing is I am not deleted Q. I deleted Q next. Maybe looking like this. If at all, this is the story order of one. Right? But I think I am not deleted Q. I deleted Q next. Right? Fine. So please, you have to praise also. You have to praise also. Don't criticize him, because he is the one who will select you, right? Who will select your future. So please careful. This is a very nice question. It is a very nice question. See, in the single linked list to go to first to last, it will take n time. In the double linked list to go first to last, n time. Because when you want to concatenate, I have to go to first to last. Right? Next one, in the circular double linked list first to last, I think you can go directly, constant. No, no. See, circular, listen, circular single linked list, last to first to last, not possible. First of all, how will you go to last? Yeah. SK is a very dangerous person. SK is a very dangerous person. He won't, right? He's saying that then if that is the case, in the right, circular single linked list also, circular single linked list last to first possible. First to last not possible, because if you want to concatenate, you are there in the first place. You want to go to last place. SK is very danger. He want everything here. He want everything. But right, like I like you, SK, I like you. Your questions are mind blowing here. You will get the nice rank, you try. You will get the nice rank, right? You will get the nice rank, you try. Your questions are mind blowing. It looks so danger. It looks so danger, but they are very good questions. Yeah, go to the question number 13. I think this one we are already done in the class. This one we are already done in the class. I think some rules are there. Division modulo method. Division modulo method. We have already some rules, right? It cannot be a prime number. It cannot be close to prime number. I think this one. It is close to, right? I think it is a close to powers of 2. 64 it is close. 64 it is close. It is also maybe 64 close. It is also 1024 close. And one more thing, it is not a prime number. Not prime. It is not prime. 9981. It is not prime. It is a close to powers of 2. It may be prime, but close to powers of 2. So this may be the answer. Yeah, this one. Double linked list means like this. He came here, he will go here. He came here, he will go here. It is a linked list L1. It is a linked list L2. Now when you do concatenation, same. The only thing is bigger one. The only thing is bigger one. So E will comes to here. E will comes to here. A, B, C, D. E, F, G, H. A, B, C, D. E, F, G, H. Like this. So the procedure is, listen, see the procedure. See the procedure. From here you goes to here, constant. From here you goes to here, constant. Afterwards, you have to adjust this. Now again from here, go to, right? Again from here, go to here. Again from here, go to here. So this person you have to inform. Go to first. This person you have to inform. Go to this. First you have to go here to here. Constant. Then adjust this. then go to from here to here. So come here, go here. Some adjustments. Right? Perfect. Chalo. Question number 13 done. Question number 13 done. So I think it is not a prime number. It is a close to powers of 2. It is a close to powers of 2. Right? So I think B is the better choice. Next one. See, everyone remember. This is the definition for, see this one. Choosing the hash function randomly from a class of hash function such that it is independent of the key. Means I selected the hash function. It will work independent of the key. That hash function is known as universal hash function. Someone is working independent of the keys. Suppose if you say only for these keys, this hash function working, then it is not a universal hash function. Only for these keys, that hash function working, then it is not a universal hash function. It is not a universal hash function. Independent of the keys, whatever keys you want, you select. This hash function is working. That is known as universal hash function. Independent of the keys, it is working. Independent of the keys, integers, then also it will work. Character, then also it will work out. Float, then also it will work out. Real number, then also it will work out. Independent of the keys, it is working. Then it is known as universal hash function. Name itself saying universal. E will work for anything. Just I want to give definition, so I given. Just I want to give definition, I given. This is the universal hash function definition. I selected one of the hash function. It is working independent of the keys. That is called universal hash function. Right? Be careful. Go to the question number 15. Yeah, question number 15 is the nice one. Question number 15 is the nice one. 15, 16 combined one. We will discuss in the group. Sir, option A, B definitions. Which one? Yeah, perfect hashing we are already covered. Right? Order of 1 every case. Uniform hashing means element can go anywhere. Simple uniform hashing means element can go anywhere. We are already covered. See, this 15 and 16 we will discuss in the group. 15 and 16 we will discuss in the group. It is a nice one. 15 and 16. Right? 15, 16 we will discuss in the group. Let's go next. It is a normal. It is very simple. I think question number 17, 1 is the answer. Sorry, I think 1 is the answer. It is a normal problem. Question number 17, it is a normal problem. You can easily do it. Question number 18, hash table of size. It is also simple, linear probing. So answer is, I think, B. Linear probing. Remember, linear probing, another name is closed hashing. Go to the question number 19. Listen everyone now. AVL tree, see this one. This is also I want to say to you, that is the reason I given this problem. AVL tree maximum height. N nodes AVL tree maximum height. Right? Remember, one theorem is there. N nodes AVL tree maximum height. N nodes AVL tree maximum height. Right? So 1.44 log n. Please remember this. It is the maximum height. Asymptotically log n. We are discussing log n. Answer is log n only. Right? But if at all really you want, this is the answer. 1.44 log n. Someone is saying question number 17C na is indirectly asking explain. 17 go. Yeah, sorry for this. C. Yeah, both. All right. Intention is right. 1 and 2 both. Sorry for that. Question number 17 answer is 1 and 2. That means C. Thank you. Question number 18B. Question number 19. I want to say this formula. Remember this. AVL tree height. Maximum height of AVL tree. 1.44 log n. Normally we used to say log n. Normally we used to say log n. Please careful. Please careful. Normally we used to say log n. So minimum, when you say minimum, right? When you say minimum, something like complete binary tree. Minimum is everyone know. Minimum everyone know. Complete binary tree. Complete binary tree height. Can you help me now? 7 nodes. What is the minimum height of AVL tree? Please give the answer to me. This is the minimum. Every level keep maximum people. Every level keep maximum people. That is going to be minimum height will come. 7 nodes are there. Log 7 plus 1 base 2. How much? 8. Log 7 plus 1 base 2. Log 8 base 2. So 3. 3 levels. It is the levels. It is the levels. You want height minus 1 you do. That is the levels. Shakir, that is the levels. Do minus 1. Then you will get the height. It is the minimum height. Minimum height is 2. Levels are 3. But do you believe or not? Here also log there. Here also log there. Both are log n. Forget about constant. Both are log n. AVL tree height is log n. Levels minus 1 is height. Exactly. This will give levels. This will give levels. Minus 1 you do, height you will get. 3 levels. 3 levels. Height is 2. When you say minimum height, AVL tree minimum height, think about, oh, minimum. So everywhere keep maximum. So complete binary tree. Complete binary tree, number of levels, this is the formula. Do minus 1, you will get height. But AVL tree, maximum height is, this is the formula. But I said one more thing also. With the 20 nodes, what is the maximum height of AVL tree possible? So that also there in the nodes, please take care that also. But all are indirectly, directly log n. To say this formula, can you remember this also? To say this formula, I given this, not to confuse you. To say this formula, I given. Any confusion is there, please let me know. I said already in the classroom, that is also correct, this is also correct, that is for, right, small number. This is for big number. Suppose the big number is given 1 lakh, log 1 lakh base to find out, multiply by 1.44. But in the classroom, whatever we covered, that is for small number. This is for big number. Right? Fine. Question number 20. Question number 20. See this one. Question number 20. Array. Listen, everyone. Using array, you are implementing queue. If you do insertion, rear will change something. If you do deletion, front will change something. So I think NQ, DQ. NQ is here. NQ is here. DQ is here. So constant. Here also constant time. Here also constant. Maybe in tomorrow's class, maybe further classes, you will get it. So what is the answer? At most, one operation can be performed order of 1 time. But the worst case, no. So what is the answer? Both will take constant time. Both will take constant time. Which option? Both operations will take order of 1 time. In the last class, we done, see this one. Queue implementation. Using linked list, we done. All are order of 1. Right? Queue implementation using array, we are not done. This is also order of 1. If you want, you can see in the next class. If you want, you can see in the next class. Implementing queue using linked list. Implementing queue using array. Already stack we done. Implementing stack. Using linked list. Constant. Using array. Constant. If anyone done anything wrong, you done. Anyone done anything wrong, identify, rectify. That is the only way. Identify, rectify. That is the no need to criticize. No need to decrease yourself. Go to the question number 21. You know very well. Unweighted graph. Single source, shortest path. The shortest path from a node, yes. So single source, shortest path. So BFS. Unweighted graph, shortest path. Unweighted. If it is a weighted, it could have been Dijkstra's. Unweighted. So BFS. Go to the question number 22. The worst case running time to search an element in a balanced binary search tree. Everyone know it is a ABL tree. ABL tree. ABL tree, worst case running time to search an element, search operation. So everyone know ABL tree for n elements, search operation is log n time. But here how many elements are there? These many elements. ABL tree search operation for these many people, n into 2 power n. So what is the answer? N elements log n. These many elements are there, log of n into 2 power n, which is going to be log mn formula, log m plus log n, which is going to be log m is log n, right? This is going to be log 2 power n. So this will goes to, right? This will goes to, let me write. This will goes to log n plus n. This will goes to n. It is a m assume, it is a n assume. Log m plus log n. Log m is log n. Right? Log n is this. If at all, if you have doubt, I will write one more time. I will write one more time. N elements are there, log n. N elements are there, log n. These are very tricky things. Small mistake, tricky things. Let's see this one. This is A assume, this is B assume. Right? It is a log AB formula, which is going to be log A plus log B. What is the log A? What is the A? So log n. What is the B? Log 2 power n, which will goes to log n plus n. Log 2 power n base 2, which became n, which will goes to n. Right. Yeah, it's theta, because every case same. So only one thing you have to understand. Only one thing you have to understand. So see this one. Right, listen, Johan, one more game I am saying to you. Johan, one more game I am saying to you. If all the symbols are similar, if all symbols are similar, please check which will be best, which is the best matching. But anyhow, you know symbols very well. No need to bring every time. Right? You know symbols very well. Right? Accordingly, you check. Symbols you know very well. Please check in the exam only. Don't check after exam is over. Right? It's a nice problem. People are, listen, many people selected ABL tree searching time log n. They selected D. Array buffoon. Some people are selected ABL tree searching log n time. ABL tree searching log n time. Array buffoon for n elements log n. N into 2 power n elements log of n into 2 power n. Log of n into 2 power n. N. Some students are blind people. ABL tree searching log n. Then this one your papa will read. This one your papa will read, or what? Who will read here? This one your papa will read. Who will read? Who will read here? ABL tree, right? ABL tree searching time log n. ABL tree searching time log n. Okay. This one your papa will read or mama will read? Who will read? Array buffoon. I don't see worst case. Then who will see? So some people are asking worst case I didn't see. I think best case also. Oh, worst case searching. Because searching an element, na. If it is the best case, na, constant. If it is the best case, na, constant. Right? Because of he's saying worst case. Right? So because of it, the searching, right? It is not insertion. Searching best case 1. Worst case n. Average case, worst case log n. Average case log n. Fine. Now can you compare? Can you compare and once? Now see this one. Johan, now see this. Because of 3 are different. See, best case 1, worst case log n, average case log n. Because of 3 are different. Now see here. Now see. The answers what we have is, everyone observe. The answer what we have is, everyone observe, best case 1. Observe clearly. Best case 1. Worst case is apply log n. Average case also log n. These are the 3 things. So you have 3 things on the left, but one thing. Listen, he mentioned worst case. Because of he mentioned worst case, see this. Because of he mentioned worst case, this will cancel. Because of he mentioned worst case, this will not work. Right? Only log n. One case only will come. This case will not come. This case will come. This case also will not come. Only one. So now check left side, right side, same. Right? So if it is right, I think after applying log, it became n. Now which option will satisfy? Check. This will satisfy. This don't satisfy. Right? I think you got it. So if anyone is confused because of me, right, I will cover one more time. Can you see one time? Because of me, if anyone is confused, can you see one time? It will take 1 minute only. Can you see one time? Yeah, see this one. So AVL tree, balanced binary search tree. AVL, searching time, worst case. See all the keywords. From all of them, listen, from all of them, I got answer. See this one, I got answer. Worst case searching time, log n. If n elements are there, log n. Now here these many elements are there. Log of this. So which will goes to log n plus n, which will goes to n. Right? Now answer is n is theta of n. This is the answer. Yeah, see, only one asking, they can give theta because only one possibility. If only one asking, he can give theta because left side only one possible. Whenever he is asking, right, whenever you don't ask anything, left many possible. So careful. See, in the previous problem, right, in one of the problem I explained, many possibilities will come. So this possibility, big O omega theta, we already discussed. Yeah, this one maybe, and this one. See here more possibility because he didn't mention. See, right, the cost of searching an AVL tree, searching, right? Sorry for this one, AVL tree searching, right? There we done one small thing. Best case 1. The cost of searching an AVL tree, right? Best case is 1, worst case log n, average case log n. Can you help me, right? Can you help me now? Now Johan come here. Everyone come here now. The cost of searching an element in the AVL tree. Best case 1, worst case log n, average case log n. Can you help me now? Are they agree with everyone? When you don't mention, you have to take all. Easy agree with everyone? Now check. Easy agree with everyone? No, is not agree. But is agree. Binary search tree, best case is 1, worst case n, average case log n. E will agree, but E is not agree. E is not agree. But what about option B? Can you check? What about option B? I think again E is not agree. Right? It is also not agree. So in the available option, maybe better option is A, but actually it is not theta. It is big O. Fine. Because no one is matching. Nah? If that is the case, no one is matching. So you can take the closest answer. You can take the closest answer if nothing is mentioned. Are you okay? See this one. The cost of searching an element in the AVL tree. AVL tree. Searching is best case 1. 1 log n. 1 log n log n. So all people are agree? No. If big O, all will agree. Big O, all will agree. Big O, all will agree. So it is also big O, it is also big O. Then option A. When you say worst case, only one person will come. Right? Fine. Now you are okay. If anyone is confused, please work on that. Please work on that. Still doubt there, in the group you can discuss. Still doubt there, you can, in the group you can discuss. Don't confuse 1 or 2 problems. Let us assume that you have doubt. You can discuss in the group. Now come to here. This problem is done. Come here. I think this one we discussed in the class also. Let's check. Let's check. A complete binary tree is a tree in which each node has n children or 0 children. Let I be the number of internal nodes. L be the number of leaf nodes in a complete binary tree. L is 41, I is 10. What is the value of n? Can you help? What is the answer? Total nodes is equal to. Is there anyone who can help me? Total nodes is equal to. What is the formula? I want answer from you. Total nodes is equal to. Can anyone help me? Every node has n children or 0 children, right? N children. So what is the answer? Internal nodes how many? 10. Internal nodes are how many? Total nodes is equal to. Internal nodes are 10. 10 into n plus 1. Am I right? Total nodes is equal to internal nodes into number of children plus 1. So what is total nodes here? What is total nodes here? What is the answer? Internal nodes 10 plus leaf nodes 41 is equal to 10n plus 1. Will you agree? It is a 51 10n plus 1, which is going to be 10n is equal to 50. N is equal to 5. Is it okay? Same. Whatever we discussed in the class. Whatever we discussed in the class, same thing. Whatever we discussed in the class, same story. Total nodes is equal to internal nodes how many? Into n array tree into n. Total nodes are this. Internal nodes plus leaf nodes. Right? This. Finally, this is the answer. This one we done already in the class. How 10n plus 1? How 10n plus 1? It is the 10n plus 1. Right? Not 100, 10n. Yeah. This one we are already done in the class. In the discrete mathematics class, it happened. Now see this one, GCD. Right? If you see the GCD, listen. If you see the GCD, always you are dividing. Divide. Right? It will go almost like log n time. Divide log n time. So if anyone having small doubt, take the 2 consecutive Fibonacci number. You will get the worst case. Consecutive 2 Fibonacci number. 2 Fibonacci numbers you take. Consecutive 2 Fibonacci numbers you take. GCD will goes to almost like log n. So Fibonacci, let me write now. Fibonacci of 0 is 0. Fibonacci of 1 is 1. Fibonacci of 2 is previous one. Yeah, these two people Fibonacci you find out. Sorry, these two people GCD you find out. These two people GCD, if you find out, it will almost going to log n rounds it will go. Right, log 13 rounds it will go. Whichever is the bigger number, that one, log 13. Approximately those many rounds it will go. So how many recursive calls made by this function? Order of log n. So that's right. I'm given also. If you want to get worst case behavior, consecutive two Fibonacci numbers you take. I take in the two consecutive Fibonacci numbers also. 8 and 13 GCD try to calculate. Answer will take log n. What is the n here? Largest number. Largest number 13. Log 13 base to you do. Right? You will get the clarity. Just verify. Right? Log n. Now come to the next one. Problem number 25. It is simple. Recursive program. This will take a T of n. This will take T of n. That will take T of n. It will take T of root n. Plus. This will take constant. Adding a number is constant. If you solve this one, log n. Right? Total nodes are leaf nodes plus internal nodes. Someone is saying, do we consider root also as internal node? Right? Root also as internal node. Of course. Of course. Right? For value, take as it is. Yeah, for value, take as it is. Yeah, I know. That is the reason I given this. See, no for loop, how can you take n? No for loop, how can you take n? It is not a function call, how can you take n? See this one. If n value less than or equal to true, return n square. Then also it will take constant. See, we are already done. So I already made one class also. Can you help me now? In algo, it is the last class or not? In algorithms, it is the last class or not? In algorithm lectures, it is the last class or not? I kept or not? In algorithm, it is the last class. In algorithm, it is the last class I kept. How to find the recursive program time complexity? How to find recursive program time complexity? It is the last class, right? I made one video I kept. I will keep this also. In your class. Right? Test number 28, I will keep this. And the only problem which I didn't explain is, it will take some time I didn't explain. That problem number is, let me read the problem number. This problem number I didn't explain. You can try in the, right? You can try in the group. If you want, I can try here itself. Sir, please take, yeah, every test I will take. Rupine, every test I will take. That is the reason for every test I give a number also. Test number 28. Test number 28 I taken. Every test I will take. Right? This one, you can try once. Otherwise, we can discuss in the group. We can discuss this one in the group. It's a nice problem. Fine? Is it okay? I don't know how much time it is taken. Yeah. So 7:30 we started, is almost like 9:30. This one you people can discuss. In the group. Okay. So I think answers for this one is going to be C, right? And this one is going to be, I think this is also C. Both are C and C. Verify in the answer sheet, it is there. In the answer sheet, it is there. Problem number 16 and 17. Sorry, 15, 16. 15, 16. Both are C's. Okay? Yeah. If anyone is preparing for GATE 2025, right? You can join EPT. Today. One offer is going on. 25% offer is going on. You can utilize this. Total 28 tests are happened, right? If you do all these 28 tests plus PYQs, it is more than enough. Sir, but sir, I don't attempt 16. 16. Can you go to the 16? Yeah, I will check 16 once. Same, na? Whatever I said. Go to the 16. See the 16. How many different insertion sequences of the key values using the same hash function and linear probing will result in the hash table shown above? Shown above. Right? See, shown above means same. It's a continuation of this problem. Previous problem continuation. Link could type. Yes, it's available. Total 100, approximately 100 tests are there. Those 100 tests followed by PYQs, more than enough. And one more, we have rank improvement course also. Rank improvement course also, that is also available. Right? From the September or October, rank improvement course also will come. Right? For the full course people, rank improvement course also free. Those people who are taking the full course, rank improvement course also free, PYQs also, and test series also. Yeah. Thanks everyone. See you in the next class. Right? See you in the next class. Thank you. Yes, Rupain. Right? September onwards, full length also will come. September onwards, full length also will come. Thanks. If any question is not okay, see this one. This is only helping only. I didn't give any answer, right? Just I explained roughly. If any question is not okay, let me ask you one thing. Listen, before my explanation, see this one. Before my explanation out of 25, you may be okay with the 10 problems. Let us assume. Before my explanation out of 25, you are okay with 10. After my explanation, you are okay with 20. Are you okay with 20? Before my explanation, you may be okay with 10. After my explanation, you may be okay with 20. Am I right or wrong? After my explanation, you may be okay with 20. Sir, you teaching DSA algorithm, but not teaching basic C language. Then what I have to teach here? I'm doing that only. I'm doing that, right? I started what is the scope problem. I started what is a scope problem. I started what is the static variable. I started what is the meaning of extern. Someone is saying only question number 14 is right, sir. Maybe you can rectify. Rupain, you can rectify. See, question number, see this one. 10 questions maybe you are already okay. After my explanation, 20 questions you are okay. If at all, right, 5 questions are not okay. Please work on that. You can post in the group. Any doubts are there, you can post in the group. Right, fine. Chalo. Thank you. Thanks everyone.